Hello everyone, so in this video let us talk about two problems. The first one is max consecutive ones part 1 and max consecutive ones part 3. So 2 is actually locked, so I will only able to solve 1 and 3 on the free version. So let us talk about both of these problems one by one. The first problem is that you're given a binary array. As you can see, you just have to return the maximum number of consecutive ones inside the array. So what you can say is that the maximum number of consecutive ones in the first example is 3, that are the last ones in this particular array, as well as in this there are 2 consecutive ones, which are these two. Now how will you be able to solve this out? It's a pretty simple and standard type of problem in which, let's say that you have consecutive ones like this. So let's say you have 2 ones, then you have a 0, then you again have, let's say, 2 ones, then you have 2 zeros, and then let's say you have 3 ones. So the answer for this is these 3 ones. Now how you will be able to do that? So what you can directly do is that you can first iterate over all of these numbers from one by one, and you can store out how many current number of ones you have seen till now. Okay, so let's say I have seen 1. So you will increment your current by from 0 till 1, that you have seen 1. Okay, then you will go to the next number. Let's say I have moved on to this number. So again you have seen 1. So now I've seen 2 consecutive ones. That is fine. Whenever you see a non-zero number that is 0, like non-1 number that is 0, you know that whatever continuous numbers I have, that is breaked, because now the continuous number of ones I have got, that is 2, and you can store it somewhere that what is the maximum consecutive ones you have seen up till now. So you have seen maximum consecutive one up till now is, let's say, equal to 2, and from 0 you will again start a fresh counting, because from 0 a new, let's say, a bracket will start and you will start from there. So what you will do is that you will store here 2 and you will start from 0 again. Okay, now you will again got 1, so you will increment it by 1. You will again got 1, increment by 1. Whenever you see 0, which means that now whatever current you are storing out, it is a current segment. So continuous number of 1. So you will check that whether it is still the maximum or it has updated. So it is still the maximum. So you will not do anything. Then you will again move to the next number. Again it is 0. So you will do nothing. Again 0, nothing. You will just start afresh. Whenever you see 1, 1, 1. Now what you can see is that I will only match the continuous segment when I am finding out a number that is non-1. Okay, if it is a 1, I will keep on appending in the current sum. Okay, like what a number of current ones I have seen. But let's say if I go out of bound, then what is the last, what about the last segment? In that scenario, what you can do is that you can explicitly add a, let's say, a non-1 digit. So let's say if I add 0 or 2 or like whatever number you can insert at the end, so that whenever I move to this number, which eventually means that it is a not 1, so whatever segment I have formed, I will just maximize it over this maximum sum and I will get the answer. So very pretty simple forward. I'll move on to the code part. It will become more clear to you from seeing that. What we have done is that I have pushed back 2 in the current, like in the current nums array, so that you can also push back 0 also. That will also run perfectly fine. So let us push back 0. Okay, because I can only have to find out consecutive ones. Okay, now what I'll do is, this is answer and this is current. So what is the current total number of ones I have seen, and the answer is the global maximum that the current continuous ones are there. Okay, iterate over all the elements inside the nums array. Whenever I have seen that it is 1, I will increment the current, because what I've seen you one, whenever I see a current number that is equal to 1, I will just keep on appending that this is a 1, just keep on appending. If it is not 1, which means that the current segment has been broken, at that particular point, whatever is the current segment, I want to maximize it with the answer, and now just make my current equal to 0, which means that I have to now start afresh from a new segment and just keep on doing that, like after we have a current segment of 1 that is maximized, just pending out the answer. That's the overall logic and the code part for the first problem. Let us move on to the second problem. The second problem is, given a binary array as in the first problem and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So you can flip at most k zeros to 1. Now you have to find out what is the continuous segment of ones you can form. In this scenario, what we have done in the previous problem is that we have continuously formed 1. Okay, we have used 1 pointer that is continuously just moving around from left to right, and whenever I find out that it is a 0, I just break out, and whenever I find out 1, I'll just keep on appending. Now instead of that, what you can do is that you can just store out that even if I find out 1, I can make it into the current segment. I'm forming a segment, let's say, like this, moving from left to right, taking this 1, taking this 1, taking this 0. Whenever I find 0 also, I will take inside the segment. The only condition is that it should be like the number of zeros I'm like flipping out, it should be less than k, because I can at most flip k number of zeros. Okay, if I can flip this number of zeros, I will keep on appending or increasing my segment. Whenever the number of zeros has crossed k, okay, then what I'll do is then I have a current segment. Okay, so let's say, let's just remove this example only, or let's remove out some red lines because those are only the problem. Okay, let's just remove out this part from here. I think so that is enough. Okay, so let's say that my k is equal to like 1. Okay, I can only append 1 0, like I can only flip. So like let's say I'm going from left to right, this is fine, this is 1, this is fine. I can do one flip, so I will do this flip, this is fine, this is fine. Now whenever I see one more 0, but I have k equal to 1, which means that I can only do one flip of 0 to 1. Then if I again do one more, find out one more 0, that is false, I cannot take that. So the current segment I have is this. Okay, now what you can directly do is this, you can use a 2-pointer technique. Let's say one pointer is pointing towards this and one pointer is pointing towards this. Now whenever you want to add a new 0, what you'll actually have to do is you have to remove a previous 0. You have to again remove a 0 from back, so that I can append a 0 in the end, which I can switch. So what I'll do is I can move this pointer from left to the right, so that where is the first 0 I will find out. Can I, like this is 0 not, can I, this is 0 not, this is 0, that is fine. So now my segment is reduced down to only 2 numbers, which means that if I have this segment, I can also add this 0 in that segment. That is fine, because if I add this, I have at most 1k, I can switch 1 0, and the segment now is this. Initially the segment was a larger one, that is it, the segment was like this. So I just have to also like maximize all the segments, like whatever the maximum segment I can get. The only condition is that k should be equal to 1. If it becomes greater than 1, I'm using a 2-pointer technique. So the previous, the left pointer should be moving on the right hand side till I will again make a number of zeros less than k. Okay, that's the overall logic that we'll be using out, and we have to maximize it over all the segments that will be forming out. So this is maximum answer that we have to return. This is the map that will store our number of zeros and ones overall whenever we are like making a particular segment. This is the 2 pointers, so I and j. Okay, the I is the previous one, the left one, and j is that is iterating over the like the string from the left to right. Okay, this is the total length. So while j is less than n, okay, what we'll do is whatever current character I am on, first I will update that inside inside the particular map that I'm building. So what it actually storing out, it is the frequency, what is the current number that I've added in the segment. Okay, whether it is 0 or 1, I will just take the current number and append it or add it inside the map, so that I have seen a 1, I have seen a 0. Now if the number of zeros is greater than k, how can I check it out? So the segment length is j minus I. J is moving, so this is j. Okay, let's say this is j and this is I. So j minus I plus 1, that is the current segment. If I subtract from that a number of ones, so I have current segment, subtract a number of ones, that is the, so this value will actually storing out frequencies, that is storing out here. If I just subtract out the frequency of ones, I will get the frequency of zeros. If the frequency of zeros becomes greater than k, that is false. So in that condition, what I'll do is I will just increment my I, that is this left pointer. Okay, I will just move my left pointer to the right hand side, and for every moment I will just subtract out the frequency of I that was eventually previously added. Okay, so first I will remove out, so let's say if I'm moving my I from this point to this point, I will subtract out this from the segment. If this is removed, so I have to also subtract out this frequency of 1 from the map. So what we have done is that I have to first remove out the frequency of 1, whatever ith character I was on, that is the left pointer. I'll have to subtract out the frequency and then move my I to the next point. I have to do this while loop until the number of zeros should be less than k. If it's greater than k, this value will continue moving out until the number of k's, like number of zeros, will be less than k, and the segment has now only zeros and ones, such that zeros are less than k. When that condition hit, I have optimal condition in which I have zeros less than k, I have certain number of ones, and the segment is completed. So I just have to maximize the segment over all the particular segments that are valid, that follow the condition such that the number of zeros are less than or equal to k, so that I can flip them equal to 1, and all the number of ones are there already. So I can directly just get the segment length by like j minus I plus 1. I can directly get the segment length, and I want to maximize it over all the segments, and then j plus plus, which means that the right value pointer, like the right pointer, should again move to the right hand side one by one, so that it will just keep on adding new elements inside segment, and whenever the segment becomes invalid, which means that the number of zeros has becomes greater than k, in that scenario only the left pointer will move to the right hand side, so that it will optimally like adjust the length so that it only has now number of zeros less than k only, less than or equal to k. Okay, that's the overall logic here. And then this is just a 2-pointer technique. You can directly understand it because I'm using 2 pointers I and j that are moving along the same string, so it is an O of n time complexity problem. So that's all the logic and the code part for the third problem as well. If you still have any doubts, you can mention out in the comment box of this particular problem. Thank you for watching the video till the end. I will see you in the next video coding, and bye.